Okay, we're going to talk about what are called multivariable equations. And what in the world do we mean by multivariable equations, let alone solving multivariable equations? Well, so far we've been solving equations, right? So for example, if I had 2a plus 7 equals a negative 3. You know, we've talked about how you would solve this. We'd subtract 7 because they're adding 7, and then we divide by 2. And in this equation, I just have one variable. I just have one kind of variable. I have the letter A. And this would be just a one type of equation with a single variable. Now what we mean by multivariable equations is where I might have something like 2a plus 7 plus b equals a negative 3. Now, this is called a multivariable equation because I have two types of letters. Now, sometimes you could have more than two types of letters. I could have 3 letters. Now, when you solve a multivariable equation, we got to pick something you're going to solve for. So, for example, in the equation that I have in the yellow, we might say, all right, solve this for A. So, in other words, the directions might be solve for A. And we try to get A isolated by itself so that we have something in the end where A is equal to something. And I'm still going to have my B there someplace also. Now this will make more sense as we continue. Now remember the steps when we solve equations. So in solving equations, for example, if I had 2 parentheses A plus 4 equals 5. Okay, the first thing we do is simplify both sides. So on the left side, I can simplify the left side by using the distributive property. I need to get rid of the parentheses. So I distribute the A. 2 times A is 2A, plus 2 times 4 is 8, equals 5. Now, is there anything else on the left side or the right side that I can simplify? Answer is no. So I've done step 1. Now step 2, pick on the small one. Now in this particular example, I kind of chose a bad example because my A is just on one side. I'm going to switch this up a little bit. For example, say that I had 2A plus 8 equals 4A plus 7. Say I ended up with something like that. Now we get all the letters A on one side, so we pick on the small one, right? 2A is the smallest. What could I add or subtract to that? Well, I'd subtract 2A from both sides. And I get 8 is equal to, let's see, 4 minus 2, 2A plus 7. So I have the equation 2A plus 7 is equal to 8. And then finally, in step 3, I isolate the variable. So I take my 2A plus 7 equals 8 and I solve it. I want to get A by itself. I want to isolate it. Isolate means get it by itself. So they're adding 7. I'd subtract 7. I'll put this in a different color. So subtract 7. And I get 2A is equal to, let's see, 8 minus 7 is 1. And then divide by 2. So 1 divided by 2 is simply 0.5 or simply 1 over 2. So A equals 1 over 2. Now these are the basic steps for solving an equation. Simplify, pick on the small one, and then isolate the variable. All right, let's keep those steps in mind now as I go through example 1. Now this is what I call a multivariable equation. Notice that my equation has both x and y in it. Now in this equation, they want us to solve for x. I want to solve this for x. I want to get x equal to something. So this term right here is what I want to get by itself. All right, so I want to get that minus 13x by itself. I want to isolate it. So what I need to do here is I need to get rid of the 8y and get rid of the minus 8. So how can I do that? Well, let's see. Remember, when you get rid of something, you actually pick on it. So what could I add or subtract to 8y to get rid of it? Well, I could subtract 8y. But then I have to do that over here, don't I? So my 8y's cancel. I have that minus 13x or negative 13x minus 8 left on the left side equals 4 minus 8y. Now I almost have the minus 13x by itself. I got to get rid of that minus 8 yet. So let's see, what could I add or subtract to a negative 8 to cancel it? Well, add 8. And you know what? I'm going to add that 8 in a little different place over on the right side. I'm going to add it right here. And you'll see why in a little bit. So on the left side, let's see, subtract 8, add 8, they cancel. And I have a negative 13x left, which is good because I want to get that negative 13x by itself. Now over on this side, on the right side, what's 4 plus 8? And I can simplify that. Let's see, 4 plus 8 is 12 minus the 8y. And that's why I added that 8 next to the 4, because I can combine those like terms. Now I'm almost done. I'm continuing to solve for x. Now all I got to do here is get x by itself. They're multiplying by a negative 13, so I'm going to divide both sides by a negative 13. So I'm dividing everything, this whole side, by a negative 13. These cancel, and all I have left is x. So my answer is 12 minus 8y over a negative 13. Now remember, you can also write that a little different way too. I can write this as 12 over a negative 13 minus 8y over a negative 13. And notice that I have a minus and a minus here. So really I could write it as a negative 12/13 plus 8y over 13. Either answer is good. This one or this one are acceptable answers. The whole thing is that we solved it for x. We got x by itself, and we isolated it on the one side. Okay, one more example. Let's take a look at example 2. Solve for p now. All right. First of all, is there any simplifying on the left side or the right side that I can do? Is there any like terms on the left side? No. Is there any like terms on the right side? Answer is no. Okay, let's go to the next step. Let's get all the p's on one side. So in other words, remember step number 1, if you went back to that a couple screens ago, simplify each side. Next, pick on the small one. All right, let's get all the p's on one side by picking on the small one. So I can add 2p here. A negative 2p is smaller than 8p. I pick on the small one. So I'm going to add 2p to both sides. So now I have 10p plus 3w equals w minus 15. All right, now solve it for p. Get 10p by itself first. All right, they're adding 3w. We're going to subtract 3w. And notice I subtracted 3w right next to this w right there, because those are like terms. So let's see, these cancel out. So I have 10p is equal to, let's see, 1w minus 3w is a negative 2w minus the 15. All right, we're almost done. Let's isolate p. They're multiplying by 10. Divide both sides by 10. These cancel. So I could leave my answer like this. The only problem is I got to make sure it's in simplest form. And how do I make sure it is in simplest form? Well, write it the way that it means. So in other words, what's this mean? It means a negative 2w over the 10 minus the 15 over the 10. It means everything in top over the 10. So I can divide, let's see, 2 and 10 by 2. I can divide 15 and 10 by 5. And what do I have left now? I have left a negative 1w, or I'll just write it as a negative w over 5 minus 3 over 2. And that is what p is equal to. So p is equal to negative w over 5 minus 3/2. Don't get too confused on this negative sign. Remember, that negative sign can go in a lot of places. It can go on the top with a w and write it over 5. It could also go on the bottom. More generally, we write it right next to the division bar, like that. Any of these mean the same thing because the whole value is negative. So multivariable equations, solving them, is the topic that we have in Lesson 32.